Okay, welcome back everyone. Now we will have a session before the coffee breaks, so we probably use the whole time. And I would like to present Francesco and Gisela. And please, take us.
Hi everyone, thanks for joining this session. So today we'll be talking about the simplest or a new way of building resilient applications. I'm Giselle van Dongen, I'm developer advocate at the Restate project, and this is Francesco.
Hi, I'm Francesco. I'm a software engineer working at Restate on the developer experience and user-facing APIs.
All right, let's dive right in. So we'll start with explaining a few things that increase the complexity in applications in the way they are built today. It's a bit related to distributed systems and to resiliency. And then after that, we'll go a bit into like a way this can be solved in a different way. So we have here a small code snippet. Imagine we have somewhere a UI where a user can create a set of subscriptions to some streaming services. For example, Netflix, Disney, Prime, this kind of things. And when he clicks checkout, what happens is we want to create a recurring payment so that the user pays every month for this set of subscriptions, and we want to actually create each of these subscriptions. So it's almost 3 lines of code, but how can we actually make this reliable? Does anyone see some issues in this code? Any ideas? Yes? Yeah, so the person in the audience said that if it crashes halfway through, we don't really know what was and what wasn't executed. So maybe we don't create all the subscriptions, or maybe we create the payment twice, these kind of issues. Does anybody else see any other types of issues of what can happen here?
Well, another one, for example, could be that this add subscriptions is called after the user clicks on the browser on some web page, and maybe the user is just impatient and is clicking more than once on this add subscriptions. So this happens to run concurrently, for example.
So these are a few of the issues. Let's actually go a bit in detail into what sort of things we would need here to make this reliable. So the first one is a bit related to what was mentioned in the audience. We need something like retries to start with in order to, if this crashes somewhere halfway through, that we don't just lose that request, but that we actually retry this execution and make sure that all these subscriptions are created. So some ways in which that can be done is that the upstream caller of this add subscription method, that one implements some kind of retry loop. Or we can put something like a persistent queue in the middle, which persists all the requests that need to be handled. But even if we have that, actually that's not enough to make this work completely well, because we then need to differentiate retries from original calls. We need to have a way to know whether during a retry, whether we already created that payment or whether it's the first time. So we need to have something like a request ID, which we then couple with the IDs that we create here. So maybe we need something like a key value store where we store the payment ID together with the request ID, and with some recovery logic, we are able to retrieve those. But so quite quickly, you see that actually something that sounds simple turns into several components of code and coordination across those. And there are some extra things there, like what if we keep all these payment IDs, after a while we need to clean those up, right? So maybe we have some cleanup jobs that are scheduled every interval or something to make sure we don't grow unbounded state there. And as I mentioned, but what's not here yet, is all the retry and recovery logic as the glue between all of those. And then we didn't talk about like some more complex cases, the one that Francesco mentioned. What if we have concurrent retries or a user clicking multiple times? How do we actually deduplicate those? How do we make sure that we only do the payment once and only every subscription creation once? We need something like distributed locks or conditional writes. And if you look at this slide, it grew quite a lot in complexity, and before you know it, you get into these kind of pretty complex architectures to actually solve issues that sound initially fairly simple. And it's hard to keep an overview of all the ways in which this can actually fail and all the scenarios that you need to keep in mind when you're writing code. So, as you see, most of these things are related to like distributed systems complexity, and you get into this quite quickly. Almost every application is a distributed system from the second that you use a database and a service. And what we are actually trying to achieve with the Restate project is to take this one abstraction level higher, so that a developer can actually use resilient building blocks in his application and doesn't need to care about the underlying distributed systems complexity that much anymore. So simplifying the way applications can be written, basically. So to structure the presentation, we'll be talking about a few different areas. The first one will be compute, then we'll talk a bit about state, and finally about communication. So when we talk about compute, there's a term that is now used for newer projects in the space that try to do this, which is called durable execution. Can we do a raise of hands of those who ever heard about the term durable execution until now? 1, 2, 3, okay. Okay, not zero, but
not zero.
At least we'll be learning something today. So the idea of durable execution is a bit the following. It's that when code is executing, it persists what it's doing, so that if it ever crashes, it can fast forward to the point where it crashed. So it basically has a memory of what it already did, so that after a crash, it can continue in the same state as where it was before the crash. So how is this actually implemented? Most systems that are out there or projects take a log-based approach in which they track in a log the progress that the execution makes. So for the case of Restate, this looks a bit like the following. Restate sits like a message broker, a bit like a Kafka message broker or reverse proxy in front of the service. And the service is just a Java application in this case, running maybe on Kubernetes. Doesn't really matter where it runs. And so what happens when we get a request to this function is that it gets proxied via Restate. The Restate server then writes down that this request took place. So in this case, user 897 wants to add Netflix and Disney. And from the second it's in that log, it's basically persisted, like it would be if it would be a message in a message broker. And from that second on, Restate guarantees the fact that it will make sure the code runs to completion. And the way it does that is it forwards this request to the function, and in the function, you see that the code statements that I previously also showed are now wrapped in ctx.run. And what that actually does is it's an SDK in the back of the service which sends journal entries of what is happening over to Restate. So every time we do something non-deterministic or something with an external effect, like writing to a database or doing an API call, we will have an entry in the journal which says that we did that. So here it's the payment ID 586, then we create the recurring payment and we have a reference. Then we add Netflix as a subscription. And now imagine that there is some kind of failure. This can be either a timeout when calling create subscription API, or it can be an infrastructure crash or a network glitch. What would happen in that case is Restate would see I was processing this request, but it never ran till completion because it doesn't see the last entry which says this got completed successfully. So it knows that it needs to retry this. And what it will do is it will just, again, send a request to this service, now maybe on another instance, and it will send over this previous log that it accumulated. And when the code now executes, every time we see ctx.run, that will basically look, do I find an entry in the log? If I find one in the log, I return whatever I find. And if I don't find one, then I actually execute whatever is in there. So the way this looks is that the payment doesn't get executed again, but we just return the previous ID. So this means we now have a stable ID that will make sure that we never have that payment 2 times. Then the payment reference, it also is already in the log. Then there's Netflix. And then when we now go to the Disney subscription, it will see I cannot find anything in the log. So that means this subscription still needs to be created. So it will do that. And we will end up with a successfully completed invocation. So that's a bit the idea of durable execution. You track the important steps in code that you don't want to have re-executed on a retry, and whenever something fails, you get an automatic retry request together with the previous progress. So let's go over to a little demo of durable execution with Francesco.
All right, so let's try to run something concretely. Okay, so we have this code. It's essentially the same code that you saw already on the slides. This is the add subscription request handler, and this is creating a payment ID. Then it's processing the payment. It gets a payment reference, and then we go over the subscriptions and we apply the individual subscriptions. And here you see that we do these operations through this context. Context run. Context random is just a shortcut for creating a random number and save it on restate. And by using the context, we make sure that everything participates in the durable execution. So we store what happens, and in case of a crash, we restart from the point where we were. Now, to start this application, what we need to do first is to start this code. And for doing so, we just use the Restate SDK that starts an HTTP server. So let's get this running. And then what we do is that we start a restate. So restate is packaged as a single binary. You just download it and you start it and it works. Now restate server. All right, we also have our ASCII art because you can go anywhere without it these days. And then the last thing we need to do, so we are going to send requests to restate, and the restate is going to proxy request to this code. But for doing so, of course, we need to let know restate where our code is. So let's open our beautiful UI, right, where we can go and register services. So in this case, we have a service that is running locally on port 9080. When you register, also Restate is going to do a little bit of introspection, seeing what are the handlers available, what are the contracts of the handlers, and all of this is useful also because it generates an open API that you can use for doing requests from the outside. All right, let's confirm it, and let's try to send a sample request. So we are going to use the playground here to just go and send a request to add subscriptions. I think it's a bit small. I hope you can see it. So let's send a request. Maybe I try to zoom this a little bit in. I think it's better. All right, and let's send a request. Let's say we want to subscribe to Disney Plus and Prime. We want a Slinky developer to subscribe here. Right. And we send a request, and everything works fine. So we subscribe successfully. Now, let's try to make this demo a little bit more spicy. And let's say that when we apply the subscription here, there is a little poison pill that when we try to subscribe for Netflix, we just throw an illegal state exception. And we want Restate to make sure that this gets retried over and over until we actually fix this bug. So we have here the project running. Now for simplicity, I'm just going to start the request from here. And we want to start this request. Okay. So we start running this add subscriptions, and we actually see that this looks like stuck from the outside, right? And if we go on the console of the service, we see that this stuck trace is moving on, right? So we see that something is being retried. Here we see that we are continuously retrying to apply the subscription Netflix, and it doesn't work. But if we look at the very beginning here, when we started the first time the invocation, we applied correctly the payment, and we applied correctly Disney Plus. And then we started failing on Netflix. And then we see here, start invocation, we retry, but we don't print anymore that we are redoing the payment again, and we are applying Disney Plus again, because that's done. Restate remembers it, and when we retry, we start from essentially trying to apply Netflix. We can also see it here. we have a way to introspect very easily what are the invocations that are currently running. So here you see that we have this invocation is at the 12th attempt stuck trying to apply Netflix, and we get the exception here. And we can also see the progress that the function did so far. So we applied the payment, we applied the Disney Plus subscription, but then when trying to apply the Netflix subscription, we are failing. Now let's fix this bug just by commenting these few lines. This is the easiest bug fix ever in my life. And let's try to start this again. And just give it a few seconds. The server starts again. And restate is now gonna retry to execute the request again without doing what was done before, just by trying to apply Netflix, and then it goes to the end invocation, and the invocation completes. And we can also see here that the client, at this point, got the request. So the external observer of the system actually didn't see that something was going wrong under the hood, just so that the function at the end completed successfully. And in the meantime, we had the chance to go and fix the bug without losing a track and without losing progress that was already done. So let's get now to the next part. All right.
Okay, so that was a little demo about the first part of the types of building blocks that we want to talk about today. So that was compute. Let's now have a bit of a look at state. So that's another place where a lot of complexity often comes into applications. And so what do we mean by state? So the example we gave until now was purely stateless. We didn't have any shared state between the methods or functions in our application. But what if we want to model a stateful entity? So basically we want to keep track of a list of the subscriptions and have one method to add some and one method to remove some. So with the idea of durable execution and tracking code execution in a log, you can actually also keep state changes in that same log. And this is the idea of modeling stateful entities, basically, and you can operate on that state via ctx.get and ctx.set. But you need a bit of extra things around this to make this actually work fully consistent and correctly. So the way we call stateful services in the Restate project is we call it virtual objects. And what's the idea? So before we had just a service, which basically was some stateless handlers, a collection of stateless handlers. In order to make that stateful, what would happen is you would have different entities that you create of the same service. And every entity has a key, in this case, user 1, user 2, and user 3. And they would still have a few handlers. And those handlers have access to isolated key value state per entity. So in this case, user 1 would have prime in his key value state, and add and remove can operate on that key value state. And so what do we gain by this? One of the things is that state changes become part of durable execution, so part of the log, which means that if it crashes somewhere halfway, we know which changes already took effect and which ones not. But can someone see an issue that we would still need to resolve here? It's something related to concurrency. So imagine that we have two requests for user 1, and they both come in at the same time. And now there are actually two functions changing the state for the same user. Then you wouldn't know anymore what is actually the last update, so you would lose the update of one of the two requests. You can get into different permutations of that problem, but it basically means you need to have the guarantee that only one handler is writing to state at the same moment in time. So the way that that looks in the Restate server that sits in front of your service is that you have a queue per key. So as requests come in, they will be added to the queue for the specific object that they are meant for. So this is a bit like Apache Kafka, where you have partitions, but in this case, the partitions are per key, not per, as in Kafka, you can have multiple keys per partition. And so what will then happen is every time an object is not executing anything, the next request would get started. The state is also kept in the server and would get sent over to the object. The object would do whatever it needs to do and would send back the log which contains the changes that need to happen to the state. So what this gives you is that the code itself, the service itself, is actually a stateless executor. It doesn't keep any state anymore related to the progress that it makes, and also not related to any key value state that it keeps, any application state. And this makes it very easy to implement and deploy them, also on something like serverless, because everything that the function needs to execute gets delivered together with the request. Just for inspiration, some types of things that you can model with this are digital twins or agents or durable actors, but also something like a durable state machine where you just have an object with some handlers that transition the state machine from one thing to another, and that's fully durable with the guarantee that you only have one handler executing at a time. Okay, let's again have a little demo with Francesco of virtual objects.
All right. So, what we saw before was a service virtual object. It didn't have any state. And now, let's say we actually want to start storing some state. And now, for simplicity, what we want to store is the subscriptions we subscribe to. And that we want to do it for two reasons. First, because we want to observe when what our subscriptions our user is subscribed to, of course. But then what we also want to do is that we want to implement another method in our user service, which now became a virtual object, to remove all the subscriptions. So let's start by looking at add subscriptions, right? This is same as before, except that at the end here, we added essentially a read modify write. We read the subscription field, we add the subscriptions that we just applied, and then we set the subscriptions field to the new value. And then the remove is pretty much the same. We get the subscriptions, we cancel all the subscriptions, and then we clear the field. And we can do this ready modify writes pretty easily because, as Giselle described, there is an implicit lock that happens on the service on a key basis. So if, for example, add subscription is running for Slinky developer, there cannot be remove running at the same time for Slinky developer. And this is what makes easy to create, like just implement these read modify writes. Now let's try to run this. Right. So as before, we start the service here. And then what we also need to do is that, okay, this is restate. What we need to do is that we need to re-register the service again. That's because Restate needs to know that now the user became a virtual object. So we do this just by the CLI. All right. And then we see that the user now became a virtual object, and there's add subscription and remove as the handlers. All right. And now let's try to send a request to this. Let's try to add subscriptions as Linky for me. We add Netflix and Prime, and then for Giselle, we add Disney Plus and Prime. So okay, that's good. Now, first, let's actually look at the state inside Restate. So Restate offers different introspection capabilities. One of them is actually a SQL shell where you can go and you can introspect the internal state of the system. So you can introspect the virtual objects, you can also introspect the internal queues, you can introspect the execution state, and so on and so forth. So let's just write a query to go and look at what are at all the available instances of the user object. So let's do select star from state. Tables, like they have a very non-imaginative names. So here we can essentially query all the state entries for all the objects. So in this case, we see that we have subscriptions for Slinky developer and for Giselle. We can also do more complicated queries because it's SQL. So like for example, we can do this one to get what are all the available instances of virtual objects. Like we can also do count here. Right? And this is going to tell me that there are two instances of the user virtual object. And then again, like we can now run, for example, the remove. We can remove Slinky Developer. And we can see here that, of course, like state was updated. So you can see how you can pretty easily get like all the introspection capabilities. You get the concurrency guarantees, and you get the ability to define these stateful entities that like let you model very easily your business logic. So yeah, let's see the last part.
So until now, everything we talked about was within the scope of a single service. So the compute was within a single handler, let's say. State was data shared across handlers. But now let's have a look at everything that exceeds that scope. So any type of communication between services. So the way this is right now called is durable futures. So future, as you all know in Java, is basically a placeholder for a future value. But in Java, it's actually managed by your JVM. If your service crashes, the future disappears, let's say. But with durable execution, if you make the future another line in that log, you can actually revive that future on another process after a crash and let the other process wait for the resolution of that future. So the idea of durable futures is making Java futures fault tolerant across processes, services, and time. And that enables two sides. So the first one is durable execution as a message broker, where here the restate service sits in between your services and proxies request response calls between services, giving you basically durable RPC. So it would make sure that if service A calls service B, that there are retries and recovery of progress for those other calls. You can also do messaging, sending a message from one service to another without waiting for the response, or even scheduling it for in 1 month or in 1 year. And then the last thing is durable webhooks. When it comes to the side of like more time-based actions, you can let a service sleep. For example, let it sleep for a week, and what would happen if that service would crash after 3 days is that it would come back up and sleep only 4 days more. So it would basically know how long it still needs to continue sleeping. And that lets you implement all sorts of things like workflow-like functions or timers, wait on an RPC call or on a timer, that kind of things. But now durably, that whenever it crashes, you can bring all of those back. And that also lets you use it a bit like a scheduler of tasks. So when we were earlier talking about like cleaning up some state, for example, imagine we have like an e-commerce application with a shopping cart, and after 15 minutes, we don't want to keep track of that cart anymore, but we want to expire whatever is in there. Like these kind of things would be very easy to implement, because you could just say like execute this function in 15 minutes and be done with it. Let's go over to the last demo with Francesco of durable futures.
All right. Now the demo gets really interesting. So let's say we have a new requirement. Our product manager comes in, says, look, before applying the subscriptions, you need to verify the user email, right? So because we are good developers, we like to do microservices. We are going to do this email verification flow as a whole in a different service, right? And how email verification works? Well, it's pretty simple in theory. You have to create a secret, then you send an email to the user, and then after that, you need to wait for the user to click on the link, and then you consider the verification done. How do we do this with Restate? Well, we can use this concept of durable futures, which in the Java API is called the wakeable here, where we can create this future that has an identifier. This identifier is going to be the same, and it's going to participate in the durable execution. So it will be stored, and in case of a crash, it will be the same over and over. And then we can send this awakeable as the secret to the user, and this secret through the email. And when the user clicks on the link, the user will unblock, complete this future, those going past line 38. So we create the awakeable, then we send the email, and then after that we await on the future. When the user clicks on the link, we complete the awakeable and the email gets verified. And we can see there on the other side, like when the user clicks on the email, it actually invokes this handler here, which takes the awakeable ID as the input, right, the secret, and then it uses our API to go and resolve the future. So we have implemented with something like 10 lines of code a non-straightforward human interaction, where you have something that is by nature asynchronous, right? You have a human interaction, something that it is asynchronous, right? And we transformed it in a code that actually looks asynchronous. Now, let's actually make this even more interesting. And let's say we have some new requirements coming in. So we have another requirement now where we want to put a global bound on this operation. So the user can click on the link, but it has at most 1 day. After 1 day, the verification expires, and the subscriptions won't be applied. And then let's say we want to add another requirement, which is every 10 minutes, we want to send the user a reminder with the same link, asking, please, can you click on the link? Can you click on the link? So basically spamming the user until the user actually clicks on the link. How do we do this? Well, we have, again, this email verification. Now I just made it a bit more complicated. What we do is we start by, we create a awakeable, we send the email, that's same as before, and then we create this verification timer, right, of 1 day. So this is the global bound for the user to actually click on the link. And then we just, we just loop. We create a reminder timer. In this case, it's 5 seconds, just for showing you how it works. And then we await for any of the features to complete. So either the user clicks on the link, so the awakeable, which means again, the user clicked on the link, so we're good, we can exit the loop. Or the reminder timer fired, meaning that we need to send the user the reminder email. Or the verification timer fired, meaning that we waited for more than 1 day. Those, we just want the whole operation to fail. And to fail the whole operation, we just throw a terminal exception, which is an exception that comes from our SDK to tell restate, please don't retry anymore this function. So you can see how, really, with a few lines of code, we actually implemented a pretty complex process. If you think about this in a classic EDA application, this is non-trivial to implement. Like, you need a scheduler system that takes care of scheduling the timers in a durable fashion. You need to remember that those timers are up and running. You need to renovate these timers. You also need probably some queue or some queuing system or state machine that is able to handle the events in a concurrent fashion. So, for example, you want to make sure you don't at the same time verify the email because the user clicked on the link, but then at the same time you got expiration, so you expire also the email verification. So you need to make sure you have concurrent access to this code. While with restate, because of this durable execution abstractions, because of the way those abstractions look like, you can easily define those awakeables, those timers as sort of events, and then wait on events in the same way you would wait on futures in your Java application. So that's how we have implemented email verification. Now we need to connect the dots. So you probably saw from the very beginning that all the classes that we use in Restate here have this service annotation. This is not the Spring Boot service annotation. Service is overconflicted term in Java. Anyway, so this service annotation, what it does is that it tells the Restate SDK that this is a Restate service, and what it also and the Restate will generate for us 2 clients to interact with the service. One client is basically a simple HTTP client that you can use, for example, from a Spring Boot application, or from a Spring Boot handler. You want to call a Restate service. You can do this using this client. It's a bit like what you get out of something like OpenAPI generator. And then it generates another client, which is a Restate context client. So the idea is that with this client, you can have one Restate service interact with another Restate service in an exactly once fashion. So again, no need to care about retries, the impotency, and so on and so forth, because when you do requests through this client, it participates in the durable execution, like everything else that we saw before, thus making everything consistent. Now, let's see how this looks in practice. So we go here. This is our user service. Okay. And then we run, we created this email verification client that was code generated for us. We call verify email, and after that we wait on the verification to complete. In case the verification goes through, this function moves on, applies the payment, and does everything it has to do. In case it fails, the rest of the function will just fail. So let's try to run this. All right. As before, we have to re-register the service because now we also added a new service to the mix. So let's do this. Perfect. And we see we have this email verification. That is a new service. And now let's try to call it. All right. So we want to apply HBO and Formula 1 TV for Slinky Developer. Okay. And this is now, I send the request, and of course it's stuck. Like it's waiting for the user to click on the link. And then we can see here, actually something is going on, right? So we see, we started the invocation, and then we sent the first time we sent the email. And then after that, we are sending this reminder email. It's always the same email, and it has always the same awakeable ID. So let me copy this over, and let me prepare the click here. Okay. And then let me show you very quick what we can see here that is actually happening. All right, so now we see here on our UI, we can see how we have the ad subscription that is running. And we see here in the journal, we call the email verification. And when we call the email verification, like we see the little spinner is telling me that this is still running. So we are still waiting on it to complete. And then we see on the email verification verify email that actually has a pretty long journal. That's because we are creating all these sleeps every 5 seconds. So every time we create a sleep, this adds up to the journal. And we see at the very beginning, we have the awakeable here that with the spinner is still waiting on the user to click on the link. And then we have this wake up from sleep in 23 hours and 59 minutes. And you know, like I can just simply kill this and restart it. All good. This is going to work completely fine. We see that at some point. There we go. We start from sending the reminder email. We don't start everything from scratch. And we also see here that we have, like we started from the point where we were. So we still have this sleep that is now 23 hours and 58 minutes. So I didn't restart from the beginning. And let's now complete this. And here we are. We submitted the email confirmation. And after that, we successfully subscribed. So with a few lines of code, we pretty much implemented what sometimes is a user registration flow, name it as you want, that does a few complex things. It has a human interaction, it has a time to the mix, and it also interacts with external services. So yeah. Let's go to the final remarks.
All right, so let's couple this back to what we started with. So the first slide we were showing was basically that handler where we were talking about all the things you would need in order to make that one actually resilient. We talked about that we need a queue for retries to not lose any requests that we need to do. We needed a distributed lock for concurrent retries. Key value store to store things like our payment IDs together with our request IDs to do like deduplication, make sure that we don't execute the payment twice. Things like timers and workflows. And so the idea of the Restate project is a bit bringing that up to a higher level. So now you just get durable primitives in your code, such as durable RPC, durable timers, future state and execution that lets you implement your business logic at a higher level with better guarantees than covering every corner case that you can come up with in your glue between all these systems. So let's have a little word about what actually is inside that server. So it's a single binary, meaning you don't need to run any databases or queues next to it in order to make it work. So it's a single thing you need to spin up. It's written in Rust. We are launching the distributed version, so the high availability version, next week. So if you're interested in learning more, we'll be publishing some blog posts on the exact internals of the log. There are already a few on our blog, so if you go to our website, you will find some more information on that. So Restate is open source, so you can use it and self-host it. It's pretty easy to self-host since it's a single binary. So you can just download it locally and try it out pretty easily. So a little bit deeper into what is inside the box itself, it's actually everything is centered around one durable log, which is a converged log which contains all the things we talked about today. It contains all the communication, all the execution updates, all key value state updates, and it's a pretty cool, interesting implementation. So it's too much to go into today, but as I said, you can find some articles already on our blog post or in the coming weeks on the details of how it's implemented. Today we showed the Java SDK, but we actually have some other SDKs as well. We have a Kotlin SDK for those that like that. There's also TypeScript. I didn't mean it like that.
I heard a laugh in the back.
There's also TypeScript, Python, Go, and Rust. So you can let different services talk to each other in that way. So one note here is maybe that if you don't use a system like Restate, you probably end up building something similar yourself. So a lot of people on our team came from several larger tech companies, actually devoting a career to solving all these issues in larger applications. And they noticed that actually many of these companies are building some form of this themselves. So Restate is the generic version that lets you implement all those use cases in just one project. So what kind of use cases are that? So the ones we showed today, of course, but you can imagine anything where you require correctness and consistency. So anything which involves money, like payments, fintech, banking, but also more complex synchronization between all sorts of systems that communicate in different ways. For example, webhook-driven workflows, or you get a Kafka event from somewhere and you then want to do an RPC, then an API call, like this kind of complex communication patterns. With virtual objects, you can also implement quite some interesting things. We have one user who is implementing a manufacturing digital twin-like use case, where in his factory, every machine is represented by a virtual object, and that virtual object is like an actor doing some operations on the machine. AI, of course, the LLM chatbots, you can do something like keep your history there and use it a bit like an agent, or orchestration workflows to do things like data ingestion and training. And then actually any other type of use case where you need retries or where you have frequent timeouts. So one common thing here is, for example, infrastructure provisioning, where you keep retrying until a machine is up and then continue to the next step in your workflow. So these kind of use cases also fit the pattern quite well. All right, that was it for today. So if you want to learn more, you can find our website documentation and how to get started on the left side. We also sometimes do things like live coding, streams, and workshops. So you can also always register for one of those. And yeah, you can rate our talk. Thanks. And if there are any questions, you can ask them now or come to us after the talk here in front.